basics of computer simulation. Computational science begins to play an important role in research and development. Nowadays, modern scientific research initially based on experiment and its theoretical interpretation, which is become a trade of experiment, theory and computer simulation. So this is because the analysis of modeling complex systems can be a gate for the discovery of important but still unnoticed simplification and patterns. Computing tools play an important role in the development and testing of new engineering products. Also, the simulation results are the basis for many decisions policies. At this time, computer modeling has such interchangeable terms as computer modeling and simulation, which are successfully used in the following areas of science and technology: design, production management, business, science, technology, architectures, entertainment, government, military, and logistics, transportations. Computer modeling is used to reduce the risk associated with creating new systems or making changes to existing ones. More than ever, modern organizations want to be sure that investment will lead to expected results. For example, an assembly line may be required to produce a certain number of squares during an 8-hour shift. Complex interacting factors affect the work, so powerful tools are needed to develop an accurate analysis. Over the past few decades, computer modeling software, along with statistical analysis methods, have evolved to provide developers with tools that fit this task. Due to the development of techniques and technology, each time the world becomes technical and further accuracy without errors is becoming increasingly important. When developing systems, business, industry, and the government cannot afford to make reasonable assumptions, and further computer modeling is more important than ever. Compared to decision-making methods, using computer simulation for analysis has the following advantages. Allows to experiment without failures in existing systems, new ideas that are difficult, costly, or impossible, as well as develop a model and compare it with the system to ensure that it accurately reflects the current work. The advantages of a modeling processes are that first, you can make any desired modification to the model. The impact on the systems under study, and then you can make a real system. Using computer simulation, it is possible to check and advance ID before setting, which allows identifying unexpected disadvantages and the construction, and these disadvantages useful for improvement and construct as instructions. The next advantage is the speed in the analysis in the simulation. The advantages of this process are that after developing a model, you can run a simulated system at speeds far exceeding those achievable in the real world. With many modeling languages, you can conduct and run several experiments, which saves time. To get results, the finished model can take from a few seconds to several hours. So this process is important for factory manufacturers to control the assembly processes. For example, every morning before production starts, engineers enter the expected system input data into their model and predict how long it will take daily work. All of above mentioned advantages of computer modeling have a common advantages, which is to reduce the risk and also reduce uncertainty. Further, increases confidence regarding the expected operation of a new system or the consequences in the existing construction. In addition to the above advantages in computer modeling, there are general limitations as follows. One of the flaws is an expensive analysis method for creating a computer model. But despite this drawback, low-cost modeling packages are available, and most of larger-scale modeling work is main enclosure in training, software, hardware analysis. The next disadvantages is laboriousness, labor intensity, which does not always give a quick answer to the questions, and in most cases, data collection, model development, analysis, and report generation take considerable time. Using two methods in the simulation process can be accelerated, reducing the specification, detailing, scaling, and the use of universal code libraries. So decline the level of detail you can get answer to the questions of the general concept much faster. But in the process of using this approach, care should be taken when removal key details that may affect the accuracy of the model. Creating a universal simulation or code library is used during the performance of many similar simulations. These reusable resources preclude reinvention for each simulation project, which is considered the basic idea. Gives only approximate answers when modeling discrete events, which is based on the use of random number generators, and in the process of modeling, the input has a random element. Some uncertainty is also associated with the output. It is difficult to verify. One of the limitations of computer modeling. Basically, the complexity of testing is reflected when the system does not yet exist, and it is important to know that the computer model accurately represents the system being studied. In such a case, the verification most often relies on the opinions of experts and intuition as a means of ensuring that the model works in the same way as the system, but whenever judgment and opinion are used, there is a possibility of error. It is often better to stick to a conservative point of view and make sure that the predicted performance of the system is now better than the expectations of actual work. In addition, the human factors in a computer simulation can be very accurate for accurate capture and simulation. Thus, the use of computer simulation is very important in research and development and allows to explore unforeseen physical or chemical properties of atoms and molecules.